Hello, everyone. So, welcome back to Math 126 homework video. And from today and in the future weeks, we will take a brief pause of like the partial derivative or vectors or any sort of other like vector geometry or calculus. In chapter 15, start talking about but multiple integrals. And we will start with double integrals. So like the double integrals, like you have integral, but it's in like two variables, is like x1 and xy. There's kind of like cubic, so just it's more complicated than what integral that encountered in Math 125. But now we will explore how to solve multiple integrals that you may count in Math 26 or Math 224. That if you're engineering major or your major requires advanced mathematics, chapter 15 is really important to you, and I hope I will give more as detailed video as possible so I can save your life because now I know it is week 6. It's very short time of the year. I want to save everybody's mental health, so please let me know if you need any help, and I'm always here with you, trust me. So we have number 2, let V be the volume to solid that lies under this graph, this multivariable function. Above rectangular region given upper 3 to 5 for x, 48 for y. We use the line x equal to 4 and y equals to 60 to divide the r, just like the as region, into subrectangles. So it's like now we're just gonna use, because like you try to evaluate like a d- double integral here, but you don't know how to get started. So here's what you can do. So it's like the larger the x and the y values are plugging into the original equation, the smaller value will be. So to get larger values for this expression, x and y need to be the smallest as it can be. So you need to be x and y, they're like smallest. So it's just like circular, like sphere or like ellipse that is like if x and y increases, like the total like output just decreases. So in this case, the L is correlated to like the lower left of the U and the upper right. So L is larger than U. And the V could be like the midpoint. So we take a midpoint and we just like can estimate it without calculation that this midpoint can be made like smaller than L. And because X and Y could be plugged in, we can also see that it would be slightly larger than U for the same reason. So L larger than V, larger than U. L larger than V, larger than U. So it's like the last one. So check the sign here. They're from a smallest to from like smallest to largest, not from largest to smallest. So be careful of this. From number 3 is like how to set up the integral. So this will be that we were talking about today. It is just how to set a multiple integral here. We have this 12 minus 6y is your function. dA, this is region. You have 0, 1, 0, 1. This can be x times y. So x from 0 to 1, y from 0 to 1. You may just think how I'm going to put on the integral like the upper bound and the lower bound. So what are you going to put? In this case, you're just going to like find it's like in the 3D Cartesian plane, and we divide it two part. There's like a solid into like a rectangular prism with a base area of one, and also it's like the triangular prism here. So you don't need to just like how you just write a new integral and just solve this integral. So just plus like the add two part of volume together. That is your volume of this solid region. So to be so there's no integral need to be set, and you just need to find an, the area. Number four here. This is gonna be very classic, like iterative integrals that you encounter in Math 126. So it's like you have x and y. So the outer integrand is corresponding to dx into dy. So if it's a dx dy, then this is dx, this is dy. So the rectangular region then is going to be x from 1 to 2, y equal to 0 to 4. In this case, you need to integrate like a dy here. So treat x as a constant. So just do so the x are all like constant. Now we do y as and now we do y as like the variables, and then we just reevaluate this double integral. So let's get started. In this case, you just like after you will get is like gonna be one and two and the one gonna be they're gonna be all change here is gonna be two and zero, and you just find like antiderivative. You just solve the internal solid integral first. Then you get the antiderivative expression. You do the anti-differentiation again. You do integration again. You will get this like double integral. So first, you just needed to like solve the inner integral first. Then go to the outer. Same with this. You just need to just ignore those like the outer integral. Just integrating as x as a variable, y is a constant. Do anti-differentiation and then just define the antiderivative expression first. Then do the integration again, and then just define this double integral. Here's the same thing. You probably write as like a product rule for x times the y, x to y to the power of negative one plus the y times x power to the negative one. Use the power rule and then just do anti do anti differentiation. For the inter one, use dy. Y is a variable, x is a constant, and you just use gonna solve find antiderivative expression. The integration again. That is your final answer for this double integral. So this particular is they're just like the area over like the rectangular region. It's not asking for just to reverse the order then integrate. There's no need to do that. It's the same thing. Like you need some like a chain rule, like a trick sub or whatever is in this case an x squared plus y squared. This is the first thing you do some like a trick sub or any kind of a like or it's kind of use substitution just to use a more advanced integral. Y is a constant and y is a variable, x is a constant. So do the anti-differentiation first, then just do another. If you use sub doesn't work, try trick sub because those are like a product rule. and it's x squared plus y squared. It's like x squared plus constant, so either tricks up or use up the work. Okay, number eight is pretty obviously this is gonna be some like you can just set up into we just try like dy dx and the y is gonna be negative 2 to 2, x from 0 to 3, just set up this interval and evaluate it. dA gonna be dx dy dx or dx dy. Choose whatever preference you that like, but make sure the inner integrand corresponding to like the first dx or dy, the first integrand goes to the outer like dy or dx. This is the same thing for number 8. Same thing for number 10. That would be okay. I mean, I'm just gonna tell for this one, you just select from the 1 to 1, and after just evaluating integral, just find a region, and to make sure from 1 to 1. So if this one is out, you just need to find those regions, and I'm gonna make. So I'm just gonna work over some harder problem doing like the final exam review. I'm sorry that I just push everything to the final exam review, but like I just want to save more time because I don't want to make a video too long. Because I know time is precious. It's gonna be like 11 minutes. So what I'm gonna do is to give a basic overview of like double integrals here. So how do you solve double integrals? So it just gonna be here, chapter 15.1. So I will just get started for here, share my screen. You can see this. This is gonna be like the general equation for like a double integrals here. There's gonna be the A region, but it's gonna be A value, but that's gonna be later. So we just need to do the same thing. We just evaluate the inner integral here, then do the antiderivative, and evaluate it again. So I will send this to the Discord and my website, but like I can't just I, I cannot just guarantee that my website will be fully updated by the end of the day or maybe sometime because I don't have time just to update it. So I would just send to Discord, and if anybody needs more like helpful study guide, and please let me know, and I will satisfy your need as possible and let me know if you need any help. And thank you so much, and have a wonderful day.